on my channel, and today we are discussing another daily Leetcode challenge. Today's date is 28 June 2022. It is a very good question, and today the solution is not very easy. I think it is a bit tricky. If you get it, you get it. It's not very difficult. It's like I could able to do it with a couple of wrong answers and brainstorming, but yeah, but you can see the thumbs ups. Good question, and let's see. And today it could be a long video, but please focus on the solution. You have to try run the solution more and more that I'll give you, and then only you will be able to understand. You might not be able to understand it clearly with my explanation, because okay, the question is tricky. Okay, let's see. But a string is called good if there are no two different characters in S. So the string is called good if there are no two different characters in S that have the same frequencies. Okay. The given string S return the minimum number of characters you need to delete to make S good. Okay, so we need to find the minimum numbers of characters that we can delete or we have to delete to make the S good. Okay, let's take some examples. So the first test is AAB. Let's see. Okay, so let's remove this. Okay, let's see. So we have A, we have A, we have B. Let's see what are the count of distinct elements. We have A, which is one distinct element. The count is 2. Next is B. The count is 1. You can see there are only two distinct elements. The first, the count is 2. The second, the count is 1, which is completely distinct. So we can see it is a good string. Okay. Let's move on to the next test case. Okay, the next test case is 3 A's, 3 B's, 2 C's. Okay, let's take. Okay, let's. A is our 3. B, how many? We have 3. And C, how many do we have? 2. So you can see that A and B have the same count, so we can just decrease B to 2. Now we have B and C same count, so we can just decrease C by 1, so we can make it 1. Now the count of all the distinct element is different, so we know how many actions do we have, how many characters we have deleted. 2, 1 here and 1 C, so the answer is 2. So this is how we do this question. Okay, now let's take another example where this problem will become interesting. Okay, so okay, let's take, okay, so let's take C, C, E, B, A, and E. Okay. Now let's take the counter. C has 1, E has 2, B has 1, A, there are 2 A's. Okay, so these are the distinct elements. Now if you see this C and you go and find out which element in the array has the same count, you can see B has the same count, you can just decrease it to 0. Now we go to E and we check all the other elements that could have the same count. So we see A has the same count, we decrease it by 1 to make it 1. Now we can skip B, the count is 0. Now we go to A and we see other elements down the array, and we cannot find it, so we can say it is a good string by just performing 2 operations. But that is not the case, because A and C has the same count. So you might think of going again to C and doing the same operation again, and that can be possible. So you can use that. What I have done is I've taken another map and I've done operation in that. Okay, so what I have done is, let's show you what my approach was with this question. So let's suppose we have A, B, A, B. We can make first mapping, which is A is 1. A, how many 2 A's we have? 2. How many B do we have? 2. So I've also made another map which will show us how many elements are there which have the count as 2, and how many elements are there which have the count. So for every count we are finding how many duplicates are there. So let's make this data set more interesting. So let's add C and E. Okay, so let's just add C. Okay, so how many C's do we have? We have 1. Okay, so now how many A2's do we have? How many elements are there which have count 2? So there are 2. And how many elements there are there who has count equal to 1? We have 1. So what our objective is to make the right side of this map equal, so that we can just tell that every there are only single element with this number of count. Okay, so we have 2 elements, A and B. So let's keep let's not change the number of elements of the number of characters, number of A's here, and just change number of B's by 1, so decreasing the count of B by 1. So so now the count will become 1. So now we have to update 1. We'll add 1 here. Now we have 2 elements which have count 1, which is B and C, and this will update it by 1. Okay, now we'll go to 1 and we see that the count is 2, which is greater than 1. We have to update it. So what we can do, we can just not delete any B's, and we delete C. So C will become 0. Okay, and here the count of 1 is only 1, which is B. Only one element is there which has the count equal to 1. And now we see that every element in the map has the same right hand side, so they are unique. No count greater than 1. So we can say that only 2 characters we have to delete, minimum 2. 1 B, 1 C. Okay, that is how I've done the question. Let's see the solution. So the solution is I've taken one map just to find the count of each unique character, and then finding another map for finding how many elements are there having the same count, and then I'm getting into the loop unless and until I find that every element in the map M1 has the same count or same value. Okay, every key has the same value in M1. Okay, so I go into M1 and found out that the I second is greater than 1. I don't want that. I want the uniqueness. So if I dot first is not minus 1 is not equal to 0, which means if this 2 minus 1 this 1 minus 0 minus 1 is not equal to 0, so I don't have to update 0 as if, like, if we have count equal to 0, then there are no elements. Like C became 0, so I don't have to update it, like C is gone. So that is what I've done. I don't consider it. So if I dot first is minus 1 not equal to 0, I will change, I will update the value of this key, which is I dot first minus 1 by I dot second minus 1. I've just left with a one element in I dot second, and rest of the elements will go to I dot first minus 1, will be added to I dot first minus 1, and count will be added, updated, and I dot second will be updated. And then here I'm just checking that every element has the same value, every key has the same value in n1, and if that's the case, which is g is equal to true, I will come out of the loop and return the count. You have to go again and again to the solution, dry run it, and understand what I'm doing. Run this video again and again, and you will get it eventually. And if you don't go to discuss a section of this problem and find out more other solutions, and you will get it. So I hope you get the solution and you understand the solution. I will come up with more better approaches and explanations for different questions. Till then, take care.